In this application, we will simulate how we can inspect bottles and cap presence or absence in a case. The first scenario, we are assuming that this is what our sample looks like. We have same type of color bottles, same size, they have a good contrast from the background. It's a triggered inspection, package is always presented in the same manner every time, and bottle placement inside is very reliable. This is what our physical setup looks like. And when we look at the SOPA software, this is how it looks. We have a pretty decent image. So we can simply teach reference object. The first approach will simply use a tool called pixel counter, which we can go ahead and draw over the field of view. The settings appear on the right hand side of the screen. 0 is black, 255 is white. We are interested in looking for bright pixels, so we'll select that intensity so that we only see the cap and nothing else. Once we are happy with that, we can shrink this down towards the center. We can adjust the pixel count as far as how many pixels we want to detect in order to verify that we have actually a cap in there. And then we can simply copy and paste this over all the 9 caps. The lighting intensity is slightly poor on this corner. It's not very uniform, so we can see that we probably need some more adjustment over here on the intensity, like that. And once we have accomplished that, we can go to the live image and kind of see that wherever the cap is there, that's a pass. Wherever the cap is not there, that's a fail. If I were to physically remove one out of the view, that would also fail. So that's the first approach. For the second approach, for the same application, I will add a different reference object. And again, we will make sure that we have a good image to start with. Once we are happy with that, we'll do the same thing, teach the reference object. This time we will use the Blob Tool. So I will click on the Blob Tool. Notice that this tool is only available in the Inspector PI 50. So I want a square shape, and I can stretch this all the way to the entire field of view. Again, 0 is black, 255 white, 0 is black and 255 is white. I can adjust for my intensity so that I'm finding only the caps which are white in color. They're still highlighted in red and not green because it's still failing. One problem with this is, for the blob, if I reduce the area over here, this whole appears to be showing as one blob, one big blob, because they are touching each other. So the assumption again was that the bottle placement are reliable. If these were narrow caps on the top and wider on the bottom, we would not have this issue because there would be separation. But because they are the same diameter all across, we have this issue. We can resolve this by inserting a virtual boundary in the middle. And I wanted a square shape, so I should have selected that. But a very thin mask in the middle on each side would take care of this and kind of create a virtual partition or a compartmentalized image for me. And once we do that, we now start seeing that we have 1, 2, 3, 4, 5, 6, 7, and this one is also showing up as a blob, 8 blobs. When we look at the blobs, they are sorted by area. So the biggest one is about 16,000 pixels and the smallest one is about 12,000 pixels. So what we can do is we can go in our tools and adjust for this to be at about 12,000, and we start discarding this one, and only the ones that are bigger than that are showing up. So this is how we would approach this application with the blobs. And now we have the number of blobs and XY coordinate for each of the blobs that is found that we can send out, or we can simply have a digital output allocation that, let's say if the number of blobs are between 9 and 9, which is how many we expect. We want that output to be pass, otherwise we want it to be fail. Okay. Now let's go and look at a third case scenario. Let's say our scenario is that the bottles can be different sizes, they can be different color, the packages are still triggered, but the presentation of the bottles inside may not be as great. How would we approach it then? If we look at it with the inspector, and I will add another reference object over here, we notice that we don't have that great contrast that we are working with over here. You know, the brown and the corrugated boxes and the white, they're kind of all in the same boat, so it's hard to do this with a 2D approach. So our approach here would be going with the IVC 3D. So here is the IVC 3D camera on the screen, and I can scan this. The laser comes on. Once we have scanned the package completely, the laser goes off. We can now go inside our IVC Studio software, acquire that image, and look at the 3D image, and there you go. You can kind of see that all the different colors represent different height. The smaller brown bottles are yellow in color, shorter. The blue ones are the big white ones. So now I can do pretty fancy things. I can simply distinguish that, hey, do I have the white bottles which are bigger in size, or do I have just the brown bottles which are smaller in size? I can even determine if there are some bottles falling down. Quite a bit of options available, because now we are not dependent on any touchy lighting mechanics. Our integration efforts is really minimized when trying to approach this kind of application with 3D. So hopefully this illustrates enough of how a SIG portfolio can be used to solve this inspection inspection of the bottles or caps inside the case. If you have any further questions, feel free to get back to us.